Hello, my name is Fatma Mahmoud Izzat Ahmed. I am 16 years old, a junior studying in Dubai National School Al Tuwal. And today I'm going to be explaining one-to-one functions from my pre-calculus class. Our objectives for today is to learn what is a one-to-one function, how to determine whether the function is one-to-one, and what is a horizontal line test. First of all, what is a one-to-one? If any two different inputs in the domain correspond to two different outputs in the range, the function is one-to-one. For example, here, the dog and the cat have the same output, so this is not one-to-one. But here, in the second graph, we have India having one output, Washington having one output, and each x has one y. Let's give you an example. For example, in the first figure, it's a one-to-one function. Why? Because each x in the domain has one and only one image in the range. While in the second figure, it's not a one-to-one function because y1 is the image of both x1 and x2. The third figure is not a function because x1 has two images, y1 and y2. Let's check our understanding. So determine whether the following functions are one-to-one. Okay, for the first figure, the domain represents the ages of five males, and the range represents their HDL, which is good cholesterol scores. The function is not one-to-one because there are two different inputs, 55 and 61, that correspond to same output, which is 38. In the second one, the function is one-to-one because no two distinct inputs corresponds to the same output. We have -2, -1, 0, 1, and 2, and we have 6, 3, 2, 5, and 8. There are different numbers. Each input has different output and each output has different inputs. Okay, so we have learned how to know if it's one-to-one using these two forms, but what if it was a graph? To know if the graph is one-to-one, we use something called horizontal line test. It is one-to-one if every horizontal line intersects the graph of a function's f at only one point. As you can see in this graph, we added a horizontal line and it intersects in two different points. So now we know it's not a one-to-one function. Let's give you a clearer image by solving this question. So in this question, they asked us for each function, use its graph to determine whether the function is one-to-one. A, we have f of x is equal to x squared, and b is g of x is equal to x cubed. Okay, for the first graph, we've drawn it, as you can see, and we've applied our horizontal line. So figure A illustrates the horizontal line test for f of x is equal to x squared. The horizontal line y equals 1 intersects the graph of f twice at 1, 1 and at -1, 1. So f is not one-to-one. In figure B, it illustrates the horizontal line test for g of x equals to x cubed because every horizontal line intersects the graph of g exactly once. It follows the g is one-to-one. Or basically we could say that every horizontal line intersects the graph exactly once, so g is one-to-one in figure B. Let's sum it up. So we have learned that one-to-one function means that if any two different inputs in the domain correspond to two different outputs in the range, the function is 1 to 1. And we have also learned that we use horizontal line test to determine whether the graph is 1 to 1, and it is 1 to 1 if every horizontal line intersects the graph of a function f at only one point. That's it. I hope you learned something new, and thank you for listening.